Hello there, welcome to video number 210. This one is on the product rule for counting. Keywords are and, product, or, and sum. And in the world of probability refers to when you multiply some things together, fractions, decimals, whatever they are. The word product means the result of multiplying. Or relates to adding, and sum is also adding. So the method states that the product rule is used when it's not possible to list all possible outcomes. All right, listing outcomes is a probability thing that you have to do. This is used when it's not possible to do that because there's too many options. You'll need to work out the number of options that are available to you for each part of the question, then multiply them together for the number of outcomes. You may need to employ the or rule if there are other ways in which you can reach a desired outcome as determined by the question. Now that makes things a lot trickier, all right? But you'll see what I'm talking about because I've got some examples for you. Okay, so question number 1 is Andy goes for a 3-course meal and he can choose from 4 starters, 6 mains and 3 desserts. How many different combinations of 3-course meal could he have? Now, typical question might have the actual starters, mains and desserts listed as well. You might be tempted to start listing them down. You don't have to, all right? So literally all you have to do for this is multiply 4 by 6 by 3. Okay, and you could do that with or without a calculator. 24 times by 3 is 72. There are 72 options. Okay, that is as simple as it can be. A lot of the time I say to students that's how easy it is, and they go, what, that's what you have to do? And you go, yeah, it is. So you have to do for that one. So yeah, you might get a nice easy one like that one, but it might get much more complicated. Now the second question is about Erin, and she spins a 6 fair identical spinners, each numbered 1 to 3. She creates a 6-digit code by putting the results of each spin together. How many different combinations can Erin get? Okay, so this is a slightly more complicated, all right? Let's have a think about it logically. So on spinner 1, she's got 3 options for spinner 1, all right? So there's 3 options there for spinner 1. You're going to multiply that by the amount of options on spinner 2, all right? And spinner 2, identical, 6 of them, fair, okay, so it's just 3 options again, and then the same again. Going to multiply by 3 and then again, so there's 3 3s, 4 3s, 5 3s, and then there will be 6 3s all multiplied together, which if you want to work out what it is in terms of power, using powers, you could write 3 to the power of 6, all right? And that's why you're allowed to jump to that straight away, really. So 3 to the power of 6, if I just move the calculator over a little bit, you can type in like this, press that button there, brings up the box, put the 6 in, and you get 729. So there are 729 different combinations that Erin could write down. Think about that logically for a second. She could get 1 1 1 1 1 1, right? All ones. The code could be all ones. I mean, it's unlikely, but it's possible. It could be 1 1 1 1 1 2, right? It's unlikely, but it's possible. They're all unlikely, very unlikely, but one of them's going to be the code, isn't it? Okay, so that's how you work that out. Anyway, what's the probability that her code is even, right? So let's think about that for a second. What makes a number an even number? Well, the only thing that you need to worry about is the last digit. The last digit needs to be a 2, all right? So the first digit of the code could be any of the 3 options. We're going to multiply that by any of the 3 options, any of the 3 options, any of the 3 options, any of the 3 options again, and then how many even numbers are there on this spinner? Well, there's only 1, all right, so we're going to put that there, all right? Now, that's basically just 3 to the power of 5. So we can work that one out by doing a very similar thing. Typing that in, getting rid of that, putting that in there, and getting 243. Okay, so the probability that a code is even, think about probability, it's not just about the options now, or the combination, number of different combinations, it's about probability. So we have to write it as a fraction, 243, out of the total number of options which we just got in the first bit of the question, 729. Alright, I hope that makes sense. You don't have to simplify, you could put it in the calculator, it might come out simplified, I don't know, I have not tried it. Now, number 3 is a proper proper difficult question, I think. I think it's quite a tough one. It melts your brain a bit, but bear with me. So there are 8 counters in a bag, 3, 3, 4, 6, 6, 7, 7, 7. Jenny takes at random 3 of the counters. She adds the numbers on the 3 counters to get her total. So she could add 3, 3, and 4, right? In which if she added 3, 3, and 4, she'd have 10, right? Just an example, right? Work out the probability that her total is an odd number. Now think about my example. 10 is not an odd number, it's an even number, all right? If she did 3, 3, and 6, right, that would be the same thing, odd, odd. So let's think about in ways in which we can make an odd number, right? So 3, 4, and 6, 3 plus 4 is 7, plus 6 is 13. That would make an odd number, but we can't keep going through all the options because there are too many, all right? So we have to think about the number of possible options there are. But let's think about all the different ways in which we could make an odd number. Okay, so let's list, so let's go odd plus odd plus odd. So if we did 3 odd numbers all added together, that would result in an odd number. Okay, and if we did odd plus even, okay, 2 evens added together would make even plus an odd, that would turn it into odd. And then it could be a different way round, the same 3 things, but a different way round. So we could have an even number first, then an odd number, and then an even number. Okay, so we're kind of listing some outcomes here, really, to decide how we would create an odd number. And then there's only one other way, if we did even, and then we got an even again, and then we got an odd, right? And that's covered all the bases of how we get odd numbers. Okay, so what we do is we decide how many options there are, right? And this is conditional, right? It's dependent upon, you know, what the first number was, right? Because they're not independent events. This is 8 counters in a bag. If you take one, it stays out. It doesn't go back in again, right? So we've got to think about how many odd numbers there are. So 1, 2. We'll look at this way of doing it first. So 1, 2, 3, 4, 5. All right. So there are 5 multiplied by, and then think about one of them's gone. All right. Maybe that one. Doesn't matter. All right. 1, 2, 3, so there's 4 there, and then for the third odd number, for us to be able to get a third one, we have to think about taking another one off, right? And that's what we need to multiply together using the same logic I've shown you in the other 2 questions. Multiply these numbers together, and that's going to give us 20, and times by 3 is 60. Okay, so that's one way of getting an odd number, by adding the 3 numbers together on the cards. Okay, if we were to do odd, even, even, right, well, we've got 5 odds first go, then we've got evens, well, there's 3 evens in the bag, so we've got multiplied by 3, and then if we had to get an even again, we'd have to take one off the 3 and get 2. Okay, so that's 30. Okay, if we were going this way, even, odd, even, it's going to be the same as this, just different way round. So even is going to be 3, and then odd is 5, and then even there's 2 left, so that's also 30, and then the last one's also going to be the same as that. So even, it's going to be 3 multiplies by 2, and then multiplies by 5, also to give you 30. Right, so this is the amount of ways you can make an odd number if we add all of these up. So add, right, so it's this way, or this way, or this way, or this way, right? So that is 60 plus 90, which is 150. 150 ways to get odd numbers. Now, we need to know the total number of ways, so because we need to write our answer as a probability. We know that the numerator is going to be 150. We need the denominator. Right, that's the easy bit of this question. There are 8 counters in the bag, so you've got 8 options for the first number. So there's 8, and then you're going to multiply it by 7, and then you're going to multiply it by 6. Okay, so if you work out 8 multiplied by 7 multiplied by 6, you get the total number of outcomes, just like in the first question, really, which is 336. So we've got 150 out of 336. All right, now that is a bit of a beast of a question. It does require some very deep thinking, I think, to get that one right. But I'm hoping it makes sense now for you. If it doesn't, give it another watch. All right. Thanks very much. Take care of yourselves. Have a lovely day. Be nice to one another. Bye.